Hi everyone, I'm Smiley. Today we are going to learn about short-term scheduling. Before we start, I would like all of you to grab a pen and prepare to take some notes. Together, we are going to score an A+ in the examination and expand our knowledge. Now, first of all, we need to understand what is scheduling. It is the process of establishing the timing of the use of equipment, facilities, and human activities in an organization. The next question is, what is scheduling for? The objective of scheduling is to optimize the use of resources and ensures that the production objectives are met. Well, how does it benefit an organization? By scheduling effectively, companies are able to use their assets more effectively and create greater capacity per resources invested, which in return will lower the costs and expenses. This added capacity and related flexibility provides faster delivery and therefore will result in better customer service. Good scheduling is a competitive advantage which contributes to dependable delivery. Now, you must be wondering, where does scheduling apply? The application of scheduling is very wide. For example, scheduling is used at the factory for the production of goods. It is also used at the hospital for the arrangement of operating room, patient admission and outpatient treatment. The university also uses scheduling to arrange the student and instructor schedules. It seems that all of you have a clear understanding about scheduling. Let us proceed to the next part. Scheduling can be done in several ways, and one of it that will be covered in this video is job sequencing. What is actually job sequencing? It is a process to determine the order in which jobs at a work center will be processed. Let's explore more about job sequencing. There are several priority roles for job sequencing. For this video, we will be covering about first come first serve, shortest processing time, longest processing time, earliest due date, critical ratio, and Johnson's rule. The first 5 rule is applicable when involving one work center, while Johnson's rule is applicable when involving 2 or more work centers. I will explain starting from the first 4 rules. For the first come first serve, the first job to arrive at a work center is processed first. For shortest processing time, the job with the shortest processing time is processed first. For longest processing time, the job with the longest processing time is processed first. And for the earliest due date, the job with the earliest due date is processed first. There are 4 important criteria that is used to evaluate these rules, which is 1. Average completion time equals to sum of total flow time over number of jobs. 2. Utilization equals to total job work time over sum of total flow time. 3. Average number of jobs in the system equals to sum of total flow time over total job work time. And 4. Average job lateness equal to total late days over number of jobs. Now, let us look into some examples. We are given an information as shown. For first come first serve, the first job to arrive at a work center is processed first. We can see that job A is the first job arrived at the work center, followed by B, C, D, and finally E. So, the sequence of job using first come first serve is A, B, C, D, E. For shortest processing time, the job with the shortest processing time is processed first. Job B has the shortest processing time, which is 2 days, followed by D, which is 3 days, A, which is 6 days, C, which is 8 days, and finally E, which is 9 days. The sequence of job using shortest processing time is B, D, A, C, E. For longest processing time, the job with the longest processing time is processed first. Job E has the longest processing time, which is 9 days, followed by C 8 days, A 6 days, D 3 days, and B 2 days. The sequence of job using longest processing time is E, C, A, D, B, or simply the reverse of shortest processing time sequence. For earliest due date, the job with the earliest due date is processed first. Job B needed to be done on day 6, followed by A on day 8, D on day 15, C on day 18, and E on day 23. The sequence of job using earliest due date is B, A, D, C, E. How do we know which sequence should be used? In order to do that, we need to evaluate these sequences using the 4 important criteria. Let's have a look on the first rule and its job sequence. Flow time is the expected time when the job will be finished starting from day 0, while job lateness is the number of late days for the job from its given due date. Using the 4 criteria, the sequence is evaluated as follows. Repeat the same step to evaluate the other rules and its sequences. Finally, summarize the criteria for all sequence. Keep in mind that no sequencing rule is perfect. First come first serve provides average performance on most scheduling criteria. It also appears fair and reasonable to customers. Shortest processing time will minimize the job flow and number of jobs in system, but long jobs may be continuously pushed back in the queue. Longest processing time is usually the least effective method of sequencing. Earliest due date usually is used if due dates are important. It also helps to minimize lateness, but the drawback is it performs poorly on many scheduling criteria. The next rule for job sequencing is critical ratio. It is an index number found by dividing the time remaining until the due date by the work time remaining on the job. Jobs with low critical ratios are scheduled ahead of jobs with higher critical ratios. It performs well on average job lateness criteria. The formula for critical ratio is given by time remaining over work days remaining, or equals to due date minus today's date over work time remaining. If the critical ratio is less than 1, it means the job is late. If it equals to 1, it means the job is just on schedule. And if it's greater than 1, it means the job has some slack or float time. Given an information as shown, by using the critical ratio formula, we calculate the critical ratio for the jobs. From the calculated critical ratio, we notice that job B is late, while job C is just on schedule, and job A has some slack or float time. So the sequence of job will be B, followed by C, and finally A. What is the advantage of critical ratio rule? Critical ratio rule helps to determine the status of specific jobs. It establishes relative priorities among jobs on a common basis. It relates both stock and make-to-order jobs on a common basis. Critical ratio rule also adjusts priorities automatically for changes in both demand and job progress, and it dynamically tracks job progress. The previous job sequencing rules is applicable when involving one work center, but what if the number of workstations is more than one? Now, this is where Johnson's rule can be applied. By applying Johnson's rule, we are sequencing a group of jobs through two work centers while minimizing processing time and minimizing total idle time on the work centers. How to apply Johnson's rule? The steps are: 1. List all jobs and times for each work center. 2. Choose the job with the shortest activity time. If that time is in the first work center, schedule the job first. If it is in the second work center, schedule the job last. 3. Once a job is scheduled, it is eliminated from the list. 4. Repeat steps 2 and 3 working toward the center of the sequence. These 4 steps can be simplified becomes list, choose, sort, eliminate, repeat. Let's have a look on one example. All jobs and times for the work centers are already listed. Now we have to choose the job with the shortest activity time. By looking at the data, the shortest activity time is 2 days for job A at work center 2. Next, we have to sort job A into the sequence. As said before, if the time is in the first work center, schedule the job first. If it is in the second work center, schedule the job last. For this case, it is in work center 2, so we will schedule job A last. After job A has been scheduled, eliminate job A from the data. Repeat the choose, sort, eliminate, repeat step until all job is scheduled. Notice that job D and E have the same shortest activity time. To schedule D and E, we have to look at where does the activity time exist on the work center. Activity time for job D is at work center 2 and job E is at work center 1. That's why we schedule job E first followed by D. Using the new job sequence, we can analyze the activities performed on the work centers. We will analyze the activities on work center 1 first. Starting from 0, the activity time of job B is 3 days. The next one is job E. The activity time for job E at work center 1 is 7 days. So, job E start after job B, which is at day 3 and done at day 10. It is continued for the rest of the job at work center 1. Next, we will analyze the activities on work center 2. For job B, it will enter work center 2 after it leaves work center 1, which is at day 3. The activity time for job B at work center 2 is 6 days. Job B will done on day 9. For job E, even though it can be started on work center 2 at day 9, it is still being carried out at work center 1, so it will be started on day 10 instead. For job D, even though it has already left work center 1 at day 20, work center 2 is still being used for job E, so it will be started at day 22 instead. The same goes for job C. For job A, the time is same, so it will started at day 33 and end at day 35. By using the activities data, we can construct a Gantt chart for both work center 1 and work center 2. Looking at the Gantt chart, the completion time is 35 days. The idle time at work center 1 or M1 is 2 days and the idle time at work center 2 or M2 is 4 days. Let's have a look at problems involving 3 work center. Before we apply Johnson's rule, we need to create a new data table by combining the activity time on the multiple work centers, becoming only 2 work centers, which can be represented as X and Y. For this case, we will combine M1 and M2 to become X. Then, we will combine M2 and M3 to become Y. List back all jobs and the new activity time. Apply Johnson's rule or the simplified version, which is list, choose, sort, eliminate, repeat to find the new job sequence. Using the new job sequence, construct activities table on work center 1, work center 2, and work center 3. Construct Gantt chart showing activities on all work center. and identify the completion time and idle time. The same goes to problems involving 4 work center. M1, M2, and M3 will be combined to become X, and M2, M3, and M4 will be combined to become Y. List all jobs and new activity time. Apply Johnson's rule to find the new job sequence. Construct activities table, construct Gantt chart, and finally identify completion time and idle time. All of these rule-based systems has its limitation. 1. Scheduling is dynamic. Therefore, rules need to be revised to adjust to changes. 2. Rules do not look beyond due dates. If it's involving 2 work centers with same due date, prioritize the most important one. 3. Rules do not look upstream or downstream. Idle resources and bottleneck resources may not be recognized. Hooray! We have reached the end of the lesson. I hope all of you have a clear understanding about this topic. If any of you have problems or want to learn more about this topic, please don't hesitate to consult with your lecturer. Do some revision and exercise, then A+ will be yours. Last but not least, wishing all of you the best of luck and bye!